morning, everyone. So let me share my screen. Yeah. See, today I would like to do a presentation on, tension members and compression members. So before that, guys, I will show you the presentations which were there with me. So this is the presentation, so which gives a complete glance on, design of steel structures introduction and some theoretical concepts. Okay, just I will go through one by one, right? So you can able to see them. Yeah. See here in this presentation, what I did is I made, I kept everything into this. So from this, you can able to get the theoretical questions from each and every point of view, right? So you can just go through the glance of this. So here I made a list of codes which requires for the steel structures, right? A few people are joining us. So, okay. Yeah. So like the materials, types of structural steel, mechanical properties, concepts of plasticity, yield strength, loads and load combinations, load buckling behavior of steel, concepts of steel limit state. Okay. So these are the contents which I made everything into this presentation. So I will try to share this presentation to you where you can refer, whenever you had a time. Okay. See the primary responsibilities of a structural steel design engineer. So here, what is the responsibility of the owner? What is the responsibility of an architect, right? The responsibility of an engineer. Along with that, what about the fabricator? So fabricator is also playing a vital role in designing the steel structures. Okay. So the contractors and state building officials. So this is how responsibility is going to be on every part. So this is the theoretical question because many times in external examination, they come across the question like, what are the responsibilities of this structural steel engineer? Okay. And see here again, guys, students are joining now. Right. See the common steel structures. So here there are few examples. So you can see one by one. Okay. Framed buildings. So this is how the complete steel structures looks like with all structural elements into that. Industrial building. So right. Then let me go fast because we are having only 35 minutes time to complete. And this is the truss bridge, suspension bridge. It is also made up of steel. Cable stayed bridge.
Sir,
right? Hello.
presentation రావట్లేదు సార్ మాకు.
రావట్లేదా? One second. One second.
Yes, sir.
ఇంతవరకు రాలేదా? అసలు ఇంతవరకు ప్రెజెంటేషన్ రాలేదా?
రాలేదు సార్.
One second. ఇప్పుడు can you see the presentation now?
Yes, sir.
Yes, sir.
Yeah. Okay.
Yes, sir.
So let me start with first. Okay. Yeah. See, I will try to share this presentation to you guys. Don't worry, I will go a bit fast. So by that I can complete within the time. Okay. So these are the codes required for the steel structures, and these are the topics which were there in this presentation. Okay. Materials, types of steel structures, and you can go with the mechanical properties, concepts of plasticity, yield strength of steel, loads and the different load combinations, local buckling behavior of steel, including pictures, and the concept of limit state design. Okay, so this is how we are going to cover each and every topic in this. And this is one of the important theoretical question. What are the responsibilities of a structural steel design engineer? Here, responsibility of an owner, architect, engineer, fabricator, contractor, and state building officials. Okay, so like this, you can go through the content over here. And again, what is the duty of this practicalities, and what responsibilities we have to take in terms of safety, in terms of cost of the structure also. So these are going to cover in this presentation. Okay, you can go through them. And coming to uh, different types of structural steel sections, sorry, different types of structural steel, structures. So like roof trusses in factories, cinema halls, crane girders, state girders, everything was pictured here. Old arch bridge, which is made up of steel, and framed buildings. Framed buildings again with each and every structural steel elements. Industrial buildings, right? Truss bridge, suspension bridge, cable stayed bridge. So this is one of the important structural design aspects, right? Whenever you start design, so these are the cyclic process. Okay, so this gives a loop from where you need to start and where you need to design. Even when you are solving the problems, first you have to assume dimensions, you have to take the structural conditions and cross sections into consideration. Then you have to start analysis and selection of cross section to satisfy the structural requirements, isn't it? Then after you have to go the design violation and initial assumptions we have to take. Say for example, if your assumptions are not in a proper, then you know you have to redesign again by assuming other different sections. When your assumptions are good and your structural design came into safe, then you can approve and it will be your final design. Okay, this is the structural design aspect. And the structural design, which includes with strength, which includes with the serviceability along with economy. This is what an optimum design of the steel structure. Like structural steel members, like we have a tension member, compression member, beam members, axial members. So each and every individual one, you can go through what exactly the tension member is and what kind of forces the tension members have. And columns, tension compression members, and beam members. What do you mean beam? So beams basically subjected to flexural loads. So what we are going to calculate in the beam members, we are going to calculate shear force and bending moment from the beam members. So that is how you can go through the structural steel members over here. Okay, and in the process and even in the frames. And here the advantages, you can have a theoretical question over here. What are the advantages and disadvantages of structural steel member? Okay, so I made every point in this one, so you can go through. If you have any doubts, you can ask me. And this is the steel manufacturing process, which I already deal in your class. And what do you mean yield strength of the steel? And steel, structural steel and its characteristics. See, what are these? They are all called mechanical properties of steel: elasticity, fatigue, ductility, toughness. These are all comes under the mechanical properties of steel section. Steel. So what are the different types of structural steel sections available? As we know, hot rolled sections, cold formed sections, built up sections, isn't it? So here I showed you what are the hot rolled sections, how they looks like. So these are the hot rolled sections where every edges are rounded edges, and they're all fabricated and manufactured materials. And these are the cold form sections, which are looks like. So basically these sections used for framed structures. So practically the cold form sections looks like this, isn't it? So I think you have seen these kind of sections for using for the frameworks. Built up sections. So obviously built up sections are made by us based on our requirements. The flanges and the webs are connected with the help of welding. So that is how the built up I sections, C sections and angular sections are made up of. Okay. Like coming to the tension members, see what type of sections can be used as a tension member. So this is also very, very important. So when you want to design a tension member, which members can you choose? So you can choose the rounded and circular solid members, and you can choose the cables in cable stayed suspension bridges and overhang bridges. In that you can use these kind of strings as a tension members. Angle can be used as a tension member, either it may be a single angle or a double angle. Okay. I sections can be used as a tension member. T can be used as a tension member, and even C sections, which are faced toe to toe, can also be used as a tension member. Okay. And coming to compression members, even I section, angular sections, hollow circular and hollow square sections can be used as a compression members. Why? Because as I already discussed with you many times, hollow sections will have more resistance towards torsion, more resistance towards buckling. Okay, so that is the reason why hollow sections and hollow rectangular or square or circular sections can be used as a columns. Okay, because they are all safe under buckling. And bending members, so usually these bending members can be used as a beams. I sections can be used as a beam. So this is a built up I section which was prepared based on the requirement. And open web joist, so the joist, in the sense joist is also a beam which connects laterally to the major beam. Angle can be used as a beam. Channels can, bending member, channel can be used as a bending member, where we use angles as a beams as a purlin. In roof trusses we are going to use purlin as a beam to support two main top chord of the roof trusses, and which will be supporting even the roofing of the roof sheet, right? It may be a GI sheet or asbestos sheet. So your purlins are going to be support the roof structure of your roof trusses. Like a composite steel structures can also be used as a bending members. So these kind of sections you can see in the flyovers, right? Recently all our flyovers are constructed with a composite steel concrete structures, right? So this is the category. So you always prefer I section as the most priority one. Why? Because I section is having more stiff compared with other sections. So that is the reason why I sections is always preferred to carry any kind of load. Then we choose channel sections and square sections, angular section and T section. This is the priority of selecting a section. Okay. Right. So here in that way, I even provided each and every notes here. So I think A section students had these notes with them. Okay. You can also go through them. The other students from apart from A section. And you can see the buckling, how, this is the buckling of the web. See, when we are discussing the beam concept, so we already gone through buckling of a beam. So why beams will buckle? Because the web is having very slender for the built-up members, because of having more slender in practical. So your in particularly beams, webs can also buckle. Okay. So by that, your web is your beam is supposed to be designed not only for shear force and bending moment, it has to be designed for beam buckling and web buckling and web crippling. Okay. So why? Because your web is susceptible to buckling and it can also be crippled at the joint. Okay. This is the portion where your web supposed to cripple. Okay. By that we have to check web under buckling and crippling. Okay. So this is the local buckling of an angle. So this is how angles will buckle when they are subjected to compression forces, right? So here stability checks I have given, and the difference between factor of safety and partial safety factors, right? So you can go through the different properties of steel sections over here, right? So the importance of an angular section. See, the angle section which you people doesn't know, this is called a bulb angle. Okay, so very important for a competitive exam summer. So I got this from Gate Masters. There will be an angle called bulb angle, which will be used for manufacturing of ships. Ship build cheyadaniki ilanti bulb angles ni use chestar. Okay, keep that in mind. So if you want, you can note that also. Okay, so regularly we have seen equal angle section and unequal angle sections, but there will be a bulb angle also available, right? So here you can see the importance of an I section, importance of the T sections. So where it can be used, for what kind of sectional properties it's have, and towards which direction your sections can be utilized. So it was clearly given over here, right? So like this, a few notes presented here, Amma. So you can just go through one by one, right? So let me go to the next PPT, which is on connections. See, one important point here I would like to show you. So even aluminum can be used as a construction material. Okay. So, but why we are not preferring aluminum much? Because even aluminum is also a ductile material, isn't it? So, but why we are not preferring? Why? Because if you take the Young's modulus of steel compared with aluminum, Young's modulus of steel is 3 times more than the aluminum. Very, very important competitive bit. Okay. So your Young's modulus of steel is 3 times more than the aluminum, as aluminum is having very least Young's modulus. So by that it is not used for carrying heavy loads. But where we are using aluminum, as aluminum is not economical than steel, so by that we are selecting this aluminum for using as a frameworks. Okay. So why? Because your aluminum will have more deformation compared with steel. So the main advantage of aluminum section is, so the maintenance cost of aluminum will be always less compared with steel. So that's the reason why we use aluminum only for windows and for the frameworks. Okay. So very important concept on this one, right? So this is how this presentation is going to be useful for you guys in terms of knowing completely about steel structures. And let me start with another screen sharing. So which is on connections. Guys, can you see this presentation? Connections?
Yes, sir.
Yeah, yeah. So now let me show you the connections. So connections basically they are classified into two categories. One is permanent connections and temporary connections, in which bolting and pin connections are comes under temporary, as you know, and welding and rivet comes under the permanent connection, right? So here I would like to show what is the difference between fastener, bolts, and screw. See, అన్ని ఒకేలాగా అనుకుంటాం, but fastener is different, bolt is different, and screw is different. Okay, so generally we call fastener is a general term, so which we describe a material which connects two parent members. So that is how we define a fastener, right? So bolt is the one which is having a proper thread, shank, and thread portion. But screw, it will have only a head and thread portion. There won't be any shank for the screw, right? So for the coming to the applications, you are going to use screw for different applications, for connecting the panels of the roof trusses and all. But coming to bolts, we are going to use bolts as a structural important element. Only 10 minutes left under. Okay. Right. So that is how we are going to use the fasteners, bolts, and screws. So let me go faster. Only 10 minutes left in Zoom app, Zoom application. Okay. And this is how the beams are going to connect to the column. And this is what a bolt, and this is called a welding, right? So we are going to study bolt as a temporary and weld as a permanent connection. Okay, connecting plates and connecting angles. So here all members are connected to the gusset plate. This is what the gusset plate. Okay, so whatever the problems you are solving, member with a gusset plate, this is what a gusset plate, right? See, the classification of connections are described here, and riveted connections, bolted connections, welded connections, bolted welded connections. And this is how the rivet looks like. It won't have any thread portion. There will be only head and shank. That's how rivet is going to be used as a permanent connector. Okay. And you can see how the rivet is going to be installed to connect two parent members. So this is how the riveting looks like. Okay, nowadays riveting is no longer used. Why? Because this riveting is going to make a structure permanent, permanent joint. That's the reason why nowadays no one is using riveting. They are all going to use temporary connections with the help of HSFG bolt, where it can able to carry heavy loads, which is called high strength friction grip bolt. Right, this is how the bearing bolts looks like. Basically, bolts are classified into two categories. One is bearing bolt and the other one is HSFG bolt. Again, bearing bolts are classified into two. One is unfinished black bolt and the other one is finished turned bolt, isn't it? So this is the bolt called a black bolt, so which is unfinished at the shank portion. Okay, there will be another bolt which is finished turned bolt, where the shank portion is finished properly and where it can be used for dynamic loads, the structure which is subjected to dynamic loads. Okay, this is how the black bolts looks like, where it gonna used for temporary structures. Right, turned bolt. So turned bolt is also called as a finished bolt, where your shank is completely properly finished, right? And ribbed bolt, where the shank is not smooth. The shank is properly ribbed, where it will have more grip length, more grip ఎక్కువ ఉంటుంది అన్నమాట ఆ bolt కి. Right? Coming to high strength friction grip bolt and advantages and disadvantages, you can go through Amma. And coming to welded connections, so where we use welded connections, what are the different types of welded connections are there. So coming to groove weld, fillet weld, slot or plug weld, you can see all the pictures over here. And what are the advantages and disadvantages of welded connections? Okay, like this. So you can see all the applications over here, how the beam is going to connect with the major beam, and how the splicing can be done, right? And don't worry guys, this is only a presentation. Every of my own lecture was there in the Facebook live, and now again by 10:30 I'm going to come live in Facebook, where I'm going to discuss on compression members, problems, and lacing and patterns. Okay, don't worry. And advantages to the type of structural elements. Mithun, are you online?
Yes, sir. Yes, sir.
Mithun, can you take a snapshot of number of candidates attended? So by that I can upload in my WhatsApp group. Okay, right. So see,
okay.
you can see the single plate angle connections like this, and double web angles like this. So we are going to discuss these concepts in eccentrical connections, Amma. Don't worry. So these are called framed connections. Okay, so this is called cleat angle. So these are going to discuss in the beam connections. So after completion of beams, then you will come to know the eccentrical loading and eccentrical connections, right? So this PPT I'm going to share you, and you can go through what do you mean slab base, how the column is connected to the slab base, right? And what do you mean cleat angle, and what are the different types of members joining to beam, column to beam, right? Column to column, right? In that way you can able to understand easily. Okay, so this PPT will definitely gonna help you in terms of understanding concepts of all the connections, right? So these are all practical pictures, and this is how the anchorage bolts inserted into concrete, where the load transfers from column to column bases, from column bases to concrete foundation. Okay, and this ends with the presentation on connections. Now I would like to show you the presentation on tension members. Okay, so this is how tension members presentation is. So here you can see the different modes of failures of a tension member. Tension member can fail in yielding, tension member can fail in net rupture, it can also fail in block shear. Okay, so you can see how the rupture strength can be calculated with the help of net effective area of critical sections, right? So every formula was there in the code. You can go through this again, or else you can go through my PPT, my lecture in Facebook. So where I was described and explained clearly about how to calculate the net effective areas for different kind of critical sections. It is for zigzag section, for chain connections, staggered connections, even for diamond patterns. I have calculated net effective area for the different critical sections.
Sir, PPT
Sir,
రావట్లేదు.
PPT pronounce it.
One second.
Yes, sir.
Yeah, so now it works.
Yes, sir.
Yeah. One second, let me come with first. Yeah. See, in the design of tension members, as I told you, there are 3 different types of failures where tension members are subjected to. So where you have to calculate the design tensile strength of these members in terms of yielding, rupture, and block shear. Okay. So as I told you, like you can calculate with the help of this formula, which was there in the code. And I think this picture was there even in your code as well. The calculation rupture strength for angle when it is connected to the gusset bed with the help of a bolt, and the angle connected to the gusset bed with the help of a welding, right? writing all these formulas there in the code. So this is how the block shear looks like, right? So very important term, block shear in the sense. So now in this picture, you can see how the block shear happens. So there are two shear planes. This is one shear plane and this is the other shear plane, isn't it? Right? So this is how the block shear happens. So the load which is parallel to the plane, that planes are called shear plane, and the plane which is perpendicular to the load direction is called a tension plane, right? So here you can see angle which is connected to the gusset plate, where you can see only the two planes. This is one plane and this is the other plane. So this plane is a tension plane which is perpendicular to the load direction, and this is the one plane which is parallel to the load direction. This is the shear plane and this is the tension plane, isn't it? See how many bolt holes are falling in the shear plane? One complete bolt hole and half a bolt. 1.5 bolt is in the shear plane and half bolt is in tension plane, right? So in that way, you can able to calculate the block shear failures, and it was clearly explained in my presentations also. And block shear failures when it is connected with the welding. So even in the welding, block means, see, you can see the block shear failure in a welding. So the complete block will fail like this when it is connected with the help of a welding. Okay. So this is how the complete welding part will come out from the gusset plate. So now you can see there are two shear planes and one tension plane. This is the tension plane, and this is, see, this plane is a shear plane and this plane is a shear plane and this is a tension plane, right? So by that you can able to calculate areas at every section. Right? And we already discussed about the lug angle, isn't it? When angle is subjected to heavy loads, so by that the length of the angle will increase, the length of the gusset plate will increase, the number of bolts will increase, which leads to uneconomical section. To make section economical, to make this joint economical, the concept we have is a lug angle. So what we do is the load acting on this angle is going to be distributed to the other angle which is connected just beside the parent angle. So this is your parent angle, and these two angles are called gusset angles, which are placed beside the main angle. So that is how these two angles are connected to the major